Welcome to Physics Chat. Today we have a very special guest, a PhD student who uses artificial intelligence to look for gravitational waves, who is usually one of the hosts of the show. Thanks for joining us, Susanna.
Thanks for having me. I'm excited to be on the show as a guest for once.
So, for those of us who aren't physicists, can you explain what artificial intelligence is?
Sure. Artificial intelligence is about creating computer programs that can learn from data and make predictions based on that data. The basic building block of artificial intelligence is the neuron, which is a computational unit that's loosely inspired by neurons in the human brain.
That's really interesting. So we're basically creating an artificial brain to solve complex problems. Can you give an example of how AI is used in astrophysics or cosmology?
Sure. One example is the use of deep learning algorithms to analyze data from gravitational wave detectors. These detectors are incredibly sensitive and they produce a lot of data that needs to be carefully analyzed to identify the signals of gravitational waves. Deep learning algorithms can be used to automatically identify these signals and filter out the noise.
Okay, thank you. That's really interesting and everything. But are you sure you're okay, Susanna? You sound a little bit different.
Yes, I'm doing well. What you've heard so far was generated by ChatGPT, which you may have heard about, but I am doing well. So that was all scripted by that language model.
Wow. So I guess artificial intelligence is just that, artificial. Sometimes it appears to be intelligent, but really has no idea what it's doing. So you do know what you're doing. How good was ChatGPT's explanation of AI?
Yeah, I would say actually really good. I would have used some of the analogies. So yes, artificial intelligence, or otherwise known as machine learning, did come from neuroscience and how we understand the brain and neurons. And so there's a lot of analogies that go from neuroscience to computer science. And I think that's really amazing how multidisciplinary science is, and how breakthroughs in neuroscience also led to breakthroughs in computer science. One of my favorite ways of explaining machine learning, and as we all know, I love food.
We have just spent the day in Geneva. It's been really lovely, had the best lasagna ever.
I flippin' love some good food, which is why I'm really enjoying myself in Sicily. If you were a pizza topping, what would you be and why? For me, I'd be pineapple because I couldn't care less what people
why?
Awful.
or not.
We can stop the recording, please.
And so let's use a food analogy. In traditional programming, you tell the computer the recipe. You say, do this, then do that, do this, and then you get a result. However, machine learning is a bit different. You say to the computer, here's the ingredients. You come up with a recipe that firstly tastes good and is healthy. So it meets some aims or criteria. So the machine will literally try out different recipes with these ingredients until it finds something that A, tastes good and that is healthy. So you can see the sort of difference in how machine learning and traditional computing works. So that's sort of how I like explaining it. But yeah, I think ChatGPT did a very good job. So well done.
Yeah, I'd say that's a really, really nice way of putting it. Personally, I think I prefer real Susanna to ChatGPT Susanna. So we should maybe stick with her for the rest of the episode. So we've got a random question for you, which we've also asked ChatGPT. Could you tell us if you had any superpower, what would it be and why?
Oh, that's a very good question. And you know what? When I first heard of this random question, I think I was going to say I would love mind reading, because I really am a bit of a nosy character and I, like to know what people are thinking. That being said, I gave this a bit more thought and then went, actually, I think it would be really cool if I could breathe underwater and I could see underwater as well. So I'm actually going with my final answer is the latter, because I love snorkeling, scuba diving, and so I'd love to breathe and see underwater.
Nice. That's a really cool, unique answer. When we asked ChatGPT, it actually gave us the answer that you would want telekinesis. So kind of similar to your first answer. It's not a million miles away. For those watching, if you want to see how easy it is to use ChatGPT, we've got some behind the scenes at the end of the video on how we used it to create the script.
Back on topic. So no more AI generated answers. So let's talk some more about gravitational waves. Could you tell us what they are and how we would go about detecting them?
Yes. So gravitational waves are ripples in the fabric of space and time, which are produced by accelerating masses. So anything creates gravitational waves. I could be clapping my hands. I could be just moving around. Everything creates gravitational waves that's en masse and that's accelerating. They are so weak, so you can't really detect these gravitational waves. However, when we have really dense objects in the universe, like 2 black holes, and they're orbiting each other, releasing gravitational waves, and eventually they collide, these gravitational waves get sent out into the universe, and we are waiting on the Earth with our detectors that are really sensitive, ready to detect these gravitational waves. In 2015, we observed the first gravitational wave from 2 colliding black holes. Black holes singing is another way of looking at it. We're just hearing the song of the black holes colliding, and we pick it up with our detectors on Earth. They are very quiet, even in our detectors, and our detectors are really noisy. So how do we go about searching for a really, really quiet signal in extremely loud data? We use a process called match filtering. So we send in these templates or mock gravitational wave signals into our noisy data, and the template that best matches the data is essentially the gravitational wave signal we observe. Another way of looking at this is, say, for example, I'm with a group of friends in a restaurant and I'm having a meal. So I want to listen into the conversation next to me because I really am a bit of a nosy character. And what I would do is I would send in mock conversations into this person's discussion. The likelihood of them talking about the fact they love aliens is extremely small. But the likelihood of them talking about how their week has been and what they've been up to is extremely high. This is essentially what we're doing in gravitational waves. We're sending in these templates or mock gravitational wave signals into the data to identify these gravitational waves.
So it sounds like you know what you're doing. You're sending these templates in. So then where does machine learning fit into this? And why would we bother using it?
The issue is with this is it uses a lot of computational resources and a lot of time to do all these calculations and identify gravitational wave signals. We're hoping to use machine learning to speed things up, to make our algorithms quicker and faster and more efficient. You know, why spend months doing something that you could do in seconds, and you're saving the environment by using less electricity, less computational resources. So that is the reason why we're interested in machine learning.
Nice. So it's really, you clearly know a lot about this, Susanna, and speak really well about it. And we know that you're very passionate about physics and physics chat. Is there anything else you would say is important in your life as well?
Yes. So for those that don't know, I'm a Christian and I absolutely love Jesus. And that's something I'm so passionate about. I would say even more passionate about than physics and physics chat. But like, this is something I think is important because I know in the media and other things, they say that you can't be a physicist and a Christian or a religion, whether you're Jewish, Hindu, Muslim, you know, these things are incompatible. And I think that's really sad because, again, personally, I believe, you know, God created science and God created science so we could enjoy it and explore his universe that I believe he created. However, I think people don't understand there's a conflict between truth. And I throw it out to the audience as like, have you even ever thought about truth? What is truth? You know, what does that mean to you? Because for me personally, science isn't truth. Science is a way of explaining what we observe. And for me, I believe Jesus is the way, the truth, and life, and therefore they're not incompatible. They are actually just looking at different things. Science is all about how this universe works and sort of the mathematics behind what's going on. But what religion is mostly focused on is sort of why we're here, why do we exist? And I think they're answering completely different questions. Only in the last 100 years that we believe that the universe had a beginning. Before that, before the evidence and science came in and more data comes in, we believed that the universe just always existed. It didn't have a beginning. So it's only in the last 100 years that now the common sort of opinion in science is that the universe had a beginning. And I think that's really interesting, that science is changing. And for me, truth doesn't change. And I encourage you guys, everyone listening, to just think about this, because I enjoy thinking about these things, but like it's also an interesting discussion about what is truth.
Yeah, it's really refreshing to hear the idea of them not being mutually exclusive. If you look back through history, at least through like Western scientists that I know of, for like example, like Newton and Galileo, you know, they weren't called scientists, they were called natural philosophers. It was using science and the scientific method to explain more about the universe with that idea of looking at religion and what God has done and things like that. So I think it's, as you say, quite a new thing that there's an at odds between science and religion, which didn't exist before.
And yeah, and like I have loads of friends who are Muslims, Hindus, and all of these that actually are scientists as well. And I love talking to them about faith and science and religion. And I just think that's just so beautiful to have so many belief systems working together for the aim of improving our understanding of the universe. I think that's incredible.
It's fascinating to hear about how you think faith and sort of science can complement one another. We know each other quite well. I know that your faith helps you a lot in your science. Are there ways as well in which your science helps you in your faith?
That is an amazing question, can I just say? And yes, there is. Firstly, you could just take, for example, when I'm just looking at how amazing the universe is and how intricate it is and how sort of mathematical it is, it just for me points to the God who created the universe and for me designed it as such an amazing way. So I believe in a relationship with God, and the whole point of Christianity is that Jesus wants to be in relationship with mankind and be a friend to mankind. God is always using science to talk to me, actually. I think one of the key ones is general relativity and quantum mechanics. So for me, quantum mechanics is all this, like, it's on the small scale, but it's all random and you don't really know what's going on. GR is on the big scales, but there is like a path that planets follow and everything can be predicted and everything follows a sort of trajectory. And for me, that just sort of describes how God works, in the sense of, in the small, you can be going about going, where are you, God? What are you doing? But in the large scale things, when you look back, actually you can see how God has moved in your life. And so that's one of the ways where I think science actually reflects the character and the nature of God.
That's interesting. Thanks for that. You talked a little bit about inclusivity, which I think is really great, and especially in science. Is there a message that you might like to give to anyone watching who's maybe thinking about a career in science?
Yes, I'm so passionate about people just being themselves in physics, and it is okay to be yourself. It's okay to have different opinions, beliefs, thoughts, political views. This is all okay. You know, we're all different. We all have different views, but we can still work together. People in the world think that unity comes from uniformity and everyone believing the same thing. And again, this is something I've shared with Field of View. It's okay to have different opinions and that's fine, but we have unity and we work together, and I enjoy working with them, and hopefully they enjoy working with me. But yeah, you know, it's we've created such an amazing atmosphere in our team, and yeah, I really encourage you to just be yourself, enjoy physics, and do what makes you happy.
Wow. That's a wonderful message. And thank you for some very thought-provoking and I think really important discussion. So yeah, Susanna, thank you so much for agreeing firstly to our fun little AI experiment. We hope you've enjoyed receiving the Physics Chat guest treatment today.
I know, it's very unusual. I'm normally on your side, so it's very unusual to be here.
And now let's take a quick look behind the scenes at how we performed our little experiment. Welcome to Physics Chat Behind the Scenes. In this episode, we'll be co-writing with ChatGPT, a powerful AI language model on the topic of physics and AI. ChatGPT will be showing on screen throughout our discussion. So for those who haven't seen it before, it looks like a chat interface where you can input text and receive responses generated by the AI. We're excited to see where this unique conversation takes us. We hope you're as excited as we are to explore the intersections of physics and AI with ChatGPT. To give a taster of how it works, let's ask ChatGPT a simple question. What is the speed of light? As you can see on screen, ChatGPT generated the answer. The speed of light in a vacuum is approximately 299,792,458 meters per second. Pretty impressive, right? Let's get started. Hi, I want to learn what AI and machine learning are with little to no prior knowledge. What questions should I ask a PhD student who uses template bank matching to look for gravitational waves to learn about what these concepts are and why they are important in astrophysics or cosmology? Not bad, but let's take a subset of these questions and incorporate them into a short script for a light-hearted chat show called Physics Chat, where said PhD student is the special guest. And sure enough, it will start writing an entire script for our chat show for us. Kind of amazing, really. Cute how it sort of like typed it all out in real time as if some human is writing a response to you. Of course, ChatGPT is just a language model, so it's only learning what humans are likely to say in responses to these kinds of questions by just sifting through huge amounts of data. You know, it has found some stuff somewhere in that data about what gravitational waves are. It's recognized AI and gravitational waves and stuff, so it's plucked out sentences or sentence fragments that are often used in those fields, but it might not necessarily apply them in the right places, right? We should fact check anything that ChatGPT says. You should fact check, because it is just a language model. It's sort of winging it and doing a good job. We've been through a few iterations, ChatGPT and I. You know, I said it's worth mentioning that there's special episodes. It's our special guest is usually one of the main hosts. I had to include, can you put in a fun random question, because Susanna really loves it. And it thinks that Susanna wants the power of telekinesis so that she can move objects around her lab more easily. I didn't know Susanna had a lab. Now I'm a little bit scared. But no, this has been fun. I think ChatGPT serves as like a really nice skeleton. If you don't know where to start for something, you can ask it for ideas and then kind of iterate on them, which is nice. Yeah, this technology is really fascinating and exciting or scary. I don't know. Let us know what you think. Can you tell when something is AI generated or not? Maybe this whole behind the scenes segment was also just AI scripted, you know? Hello and welcome to Physics Chat behind the scenes. I'm going to be showing you how we use ChatGPT to write this episode of Physics Chat behind the scenes. I need a short opening segment to an experimental physics chat behind the scenes. Nice. So it wants us to ask about the speed of light. That's pretty cool. And they should then go on afterwards to asking what questions to ask an AI expert to learn about AI. It's kind of crazy that we're asking an AI what questions we should ask about AI to learn about AI. So yeah, it's nice, pretty cool. But I would say, I mean, everything the host is saying is good, but should include some filler sounds intermittently so that it sounds more natural and the audience can't tell they're listening to something scripted. I mean, look. Oh, this is so cool. It's giving me pauses, it's giving me where to clear my throat. I don't have to do anything of my own creativity. My job is redundant. Imagine if right now I'm also being written by ChatGPT. How do you know? How would I know? This was fun. Hope you've enjoyed this episode of Physics Chat, and happy April Fool's Day.